Welcome to another exciting segment of Math with Miss Bennett. Today we're going to talk about histograms. Histograms are a way to display large amounts of data by putting data into equally sized intervals and drawing a bar to represent the frequency within the intervals. So with histograms, we often end up wanting to create frequency tables. Which are simply means of organizing our data for the sake of frequency. They might sound a lot like bar graphs, but they are not bar graphs. And we'll actually go into some more detail about that after we do a histogram together. Alright, so here I have a rather large data set. And the thing about histograms is they're particularly good for large data sets. This is when it gets a little overwhelming to draw a dot for every data value. So the first thing I'm going to need to do is create a frequency table. I'm going to need to decide on intervals that will represent my data. So if I look at my data, I'm going to find the smallest number in my set, which I believe is a 2. So my intervals have to go as low as 2 and as high as 20. So for the sake of ease, I'm going to pick a number that will give me a couple of intervals, and I'm going to go with intervals of 4. So I'm going to go from 1 to 4, which is 1, 2, 3, 4. 4 numbers in my interval. Then from 5, so 5, 6, 7, 8, another 4 numbers in my interval. 9, 10, 11, 12. 13 to 14, 15, 16. 17, 18, 19, 20. So those are my intervals. Now every time I find a number in those intervals, I'm going to mark it off and draw a tally. So I've got 10, that belongs here. 11 belongs here. 10 belongs here. 9 belongs here. 4 belongs here. 3, 10, 2, 8, 15, 13, 10, 9 goes here, 4 goes there, 8 goes here, 7 goes there, 2 goes here, 2 goes here, 2 goes here, 2 goes here, 3 goes there again, 6 goes in this one, 4, 9, 8, 5, 5, 12, 20, 3, 5, 7, 9, 11, 11, 14, 13, 12. Again, you can tell that's a lot of data. That's 511 plus 9 plus 12 plus 5 plus 1. That's 10, 7, 18. That could be 38 data values right there. And personally, I don't feel like making 38 dots. So this is a great time to make a histogram. Now I've created the start of a graph. I'm going to put my intervals in the x-axis or horizontal axis. So my intervals are 1 to 4, 5 to 8, 9 to 12, 13 to 16, and 17 to 20. And While my frequencies go as high as 12, I don't want to make 12 marks. It'll get a little cluttered. So I'm going to count by twos. 2, 4, 6, 8, 10, 12, 14. And there's no harm in going above what you need. It makes your graph a little bit neater, in my opinion. Now I'm going to create the bars for the frequencies. So the 1 to 4 must have a bar height of 11. And I'm going to write these in numerically because I like to see them that way. So the bar for 1 to 4 has 11 data values. So what I'm going to do is I'm going to find in between 10 and 12. And you're going to notice that you have to go all the way over. There's no space. The bar takes up the entire bit of the frequency, and that's okay. In fact, that's how it's supposed to go. You're not supposed to have spaces in a histogram. That's part of what makes it different than a bar graph. It's trying to demonstrate what we call continuous data. I am going to neaten this up just a little bit. All right. Next bar should be 9 high, so in between the 10 and the 8. And I'll color that in. Notice I didn't leave any space. Remember, this is not a bar graph. You can't have spaces. The next height is 12. So I'm going to try and line that up as best as I can. Shade that in. My next bar has a height of 5, right in between 6 and 4. Shade that one in. And my final bar has a height of only 1. And there you have it. I've created a histogram. Now, normally histograms get labels. There would be a label here. And of course, in this case, I'm going to label it frequency. But normally you'd have some sort of units to label down here too. Like, what are these intervals numbers of? Are they minutes? Are they inches? Are they years? Whatever those numbers may represent. And then you typically also give them a title. But I didn't make up a title for my data set. I just made random numbers. What's great about histograms is they can give you an idea of the spread and the center of the data. We can tell that the interval with the highest amount of numbers inside of it is the 9 to 12. I'm just going to draw a little arrow there. The mode is somewhere in the 9 to 12 range. We could actually find the median with a bar graph, a histogram like this. Although it's a little bit messy, you kind of have to eliminate as you go. My personal favorite way to do this is to actually turn the bar graph, the bars of the histogram, into a dot plot. So because there are 11 values, I made 11 dots. For this one, there are 9 values, so I'm going to make 9 dots. For this one, there's 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For this one, there's 5, 1, 2, 3, 4, 5, and 1. Now that I've got it in the form of a dot plot, I could actually eliminate and find where the median is. Now, I mean, I could use my data, but what if you didn't have the data? With a histogram, you're often not given the data because the data list is pretty big. You can still find where the median is, you just won't know what it is exactly. Because you could mark off the highest, lowest, highest, lowest, highest, lowest, high, low, 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 high, low. So these two are where the median would be. So we can also tell that the median, whatever it is in the 5 to 8 interval. Without the actual data, we couldn't know exactly what it is. And of course, without the actual data, we could not find the mean either. But we can take a look at the spread of the data, because this graph tells us that our data is pretty well distributed to the left. It has a little bit of left side skew. Now, with a histogram versus a bar graph, but here I've got a bar graph on the left and a histogram on the right. Let's look at a few similarities. Each of them have bars. They each have a y and x axis, and they both display data. Each also has typically some sort of a frequency marker on the y-axis. However, there are some big differences too. Notice the kind of data that's in a bar graph. Bar graphs can show what we call categorical data. This is where you get fun categories and everyone picks one. We use histograms to show numerical data. Also, you may notice the spaces. Bar graphs will always have spaces, or at least should if they're well made, and histograms will have no space. Now, sometimes you'll see a blank. This means it has a frequency of 0. So it's not a space. It just means for these test scores, nobody scored from 1 to 20, which I would say is a very, very good thing, and you would want there to be 0 data values in that bucket or interval. So notice that nobody has a score of 1 to 20, and that's the only reason why there is a gap. And you see that histograms are a little bit more complex and a little bit more advanced than bar graphs. They have sort of the same feel. So I wanted to rehash this exciting segment of Math with Miss Bennett. Why are they not bar graphs? Let's just put here bar versus histogram. So let's recap. Bar graphs have spaces. Histograms have no spaces. Bar graphs can show us categorical data. Histograms show us numerical data. Bar graphs are often discrete data. Things are counted. And histograms are often what we call continuous data. Things that are measured, so that decimals and fractions are totally okay. But this is my exciting segment of Math with Miss Bennett, in which we describe how to draw and read a histogram.